Okay, so we're gonna pick up where we left off in the previous video, where we're now getting to the data. Right, we're doing assignment 4 of this class. I think that's in week. Is it 4 or is it 5? I don't know. Anyway, okay, so we have managed to get down to the data part of the file. We now want to start reading in the data and building a pixel matrix. Well, since we're going to build a pixel matrix, we might as well declare and malloc a pixel matrix. So that's going to be a struct. What is it? PPM pixel pointer. I'm going to call it matrix. And we're going to malloc size of struct PPM pixel times the number of pixels, and that's going to be width times height. So there's width times there is height. So we've malloced the matrix. I'm going to need an index to march me through it, and I think I can just fill the matrix one coordinate after another, because I'm only doing this as, like strictly speaking, like at the hardware level, this is a one-dimensional matrix kind of. Or yeah, one dimension. It's an array basically. But I'm going to try to manage its, coordinates and so on so that it behaves as if it were a two-dimensional one. But, we'll see more about that later. But in any case, the main upshot is that I can just fill its coordinates one after another. So I just want to have an index initialized at 0, and I will simply march that index along every time I build a pixel and just put it in that place in the matrix, right? There's no need for fancy stuff is basically what I'm getting at. So next I need some way of progressing through the data. Maybe now's the time to start building the while loop. And to progress through the data, we're going to use the recommended method from the assignment instructions of using, what was it, fscanf, right? File scan format. And that is going to take, okay, so the file, so that's fptr. Then there's the const char star, so that's a string. So I'm going to put my line there. Or no, sorry, that's not that. That's the format. That's the format string. So that should be the thing that it said in the assignment, which was %HHU, I think, %HHU, %HHU. And that's going to fill, oh, right, my red, green, blue, which I need to declare, but I'll do that after I confirm that, yes, it is %HHU. Okay. And that's a char, what was it? Unsigned char. So that's an unsigned char. So I want to declare unsigned char RGB. And so that's what's going to get filled over here. So this is going to be the address of R, the address of G, the address of B. And so fscanf, when you call that, right? Like when you fill some, variables using fscanf, right? By trying to basically detect this pattern in the string, we need a signal for when we reach the end of the file. And that's, in principle, that should happen when, when this thing is no longer finding matches, basically. And so the function fscanf returns a signal telling you basically how many matches it found. It should typically find 3. So long as it finds 3, we would like to progress or like continue in the while loop. And that 3 will be the return value of the function. So long as it's finding 3 matches to fill these variables, then we continue doing something with these matches. And so, okay, so that's right. So presumably at this point in the program, we should now have 3 unsigned char values. And we would like to make, oh yeah, and so I probably want to declare the pixel, ppm pixel, that is going to, although actually I need to make a new one over and over again, so I probably want to declare it here. Struct ppm pixel p, and then p.red should equal star r. Oh, what is something not right here? Oh, yes, sorry, right, because they want pointers, right. Okay, and then p dot green is G, p dot blue is B. And now I want to take this and put it into the matrix. So matrix at I is P. I'd like to progress I. And I wonder if that is everything. I think that might be everything. So hopefully that should eventually terminate the while loop because it reaches the end of the file, no longer fills the variables, and then we break out of the while loop. At that moment, the matrix should be full of pixels. So not sure if I need to do anything else. Oh, I should make sure that I remember to free whatever I malloc, and I malloced the matrix, and I'll make the pointer null. But yeah, maybe what I want to do next is just print the result to make sure that it looks right and test it out. So let's say for int I equals 0, I less than the, what is it, the height, I plus plus, for int j equal to 0, j less than the width, j plus plus, and then I want to print the pixel at this coordinate. So let's say printf. I'm going to say r %d g %d b, and this is going to come from matrix at coordinate I times the width plus j. In fact, I'm going to use that, right? Like I want to use it over and over again. So maybe I should just declare it. And so maybe actually up here, I'll just declare struct ppm pixel p. And at this point, I'll say that p holds that matrix value. And now here I can simply call p dot red, p dot green, p dot blue. Nice, easier to read, shorter writing, so on, so on. Okay, so that should print, and then I'd like to print a new line at the end of each row. All right, let's see. What did we do here? Make. All right. Yes, this looks exactly right. That is how it should look, because the first thing is all zeros. So let's just glance over here and make sure. The first thing is all zeros. The next thing is 100, 0, 0, and so on. Okay, so it can print. Let's test it on another one that's ASCII. I only want to test it on ASCII. So let's test it on mystery 1. So what if I came over to test and I said do this to mystery 1 ASCII. First several things should all be 125. Let's take a look. Why didn't it, oh, because it has wide rows, so it doesn't line break as often. But the first several pixels should all be 220 or 255s. So when we get to the top, oh, it ran out of space. So, but it looks like a whole bunch of 255. So I think it's right. I mean, you know, like no error messages or anything. So this is promising, right? I don't need to dig too much deeper. I'm fairly confident that this is working as intended. So, oh geez, is there anything else, or is this it? So let's go back to setting that to p ASCII.ppm, and let's save that. And there was the, and is there anything else it's supposed to do? Oh, right. And I should probably be checking for null. Should return null if the memory cannot be allocated for the image data. So I don't think I did that. Yep. And so normally you would do a different kind of check after you malloc, but here we'll just say if not matrix, then oops, what happened? Then return null. Did I malloc anything else? Do I need to worry about anything else? I think I'm okay. Oh, I need to free the line. So let's make sure we do that. All right, let's look at the instructions just to make sure. Function return. Oh, did I ever return the pointer to the array you created? I need to make sure I do that. So, right, I need to return, that returns 0. That must be very wrong. That should be return matrix. Not that that should change the behavior of test. because all that does is call the function and the function does the printing. But let's just recompile anyway. Okay, that looks right still, so good. Okay, let's keep going. So you should assume that it's safe. Okay, we use fscanf. Don't forget to free your data. Is there anything I'm missing? It should look like this. And I could format it that way. All right, I think we're done with the first part.